Good morning, students. Last lecture I have discussed sharpness of resonance. Now next point in the topic, AC circuit is AC bridge. So in the 12th science you have studied Wheaton's network, Meter bridge, Kelvin bridge. So Owen's bridge is one of the type of AC bridge. So this is the circuit diagram for connection of Owen's bridge. First, resistance R1 is connected in the arm AB. Inductive coil L having resistance R2 is connected in the arm BC. Then capacitor C4 and resistance R4, they are connected in series in the arm CD, and capacitor C3 is connected in the arm AD. Now between the points B and D, head pole is connected. HP means head pole, and between the point A and C, source of alternating EMF is connected. Alternating EMF equal to E0 sin omega t. Now let Z1 impedance of the arm AB, Z2 impedance of the arm BC, Z3 impedance of the arm AD, and Z4 impedance of the arm CD. Then according to Wheaton's balancing condition, we know that R1 by R2 is equal to R3 by R4, or we can write Z1 upon Z3 is equal to Z2 upon Z. Now in the Owen's bridge, the value of resistance R1, resistance R4 and capacity C4, they are so adjusted that there is minimum sound in the head pole. Or if galvanometer is connected between the point B and D, galvanometer shows zero deflections. So this is the balancing condition, and according to balancing condition of Wheaton's network, we can write impedance Z1 divided by Z3 is equal to impedance Z2 upon Z4. So say it is equation 1. Z1 upon Z3 equal to Z2 upon Z4. Now we can write Z1, that is equal to resistance R1. So Z1 is equal to R1. Z2, that is total resistance, that is R2 plus resistance of the coil L in terms of complex number JWL. So resistance of the coil L is J omega L, and this resistance R2. So we get Z2 equal to R2 plus J omega L. Now we get Z3, that is resistance of the capacitor C3, that is equal to 1 upon J omega Ct. And finally impedance of the arm CD, that is Z4, is equal to these R4 plus 1 upon J omega C4. Now say this as common equation number 2. So equation 2 gives the values of impedances Z1, Z2, Z3, Z4. Put equation 2 into the equation 1. So we get value of Z1, that is R1, divided by Z3, 1 upon J omega C3, 1 upon J omega C3, equal to value of Z2, that is R2 plus J omega L, R2 plus J omega L, divided by value of Z4, that is R4 plus 1 upon J omega C4. Now we get equation R1 divided by 1 upon J omega C3 equal to R2 plus J omega L divided by R4 plus J omega C4. Now we can solve the left hand side. R1 upon 1 upon J omega C3 can be written as J omega C3 R1 upon 1 equal to right hand side as it is R2 plus J omega L divided by R4 plus 1 upon J omega C4. So we get the new equation J omega C3 R1 divided by 1 is equal to R2 plus J omega L divided by R4 plus 1 upon J omega C4. Now take the cross multiplication. 1 into this bracket R2 plus J omega L and this bracket into this. So we get 1 into R2 plus J omega L. So 1 into R2 plus J omega L, that is R2 plus J omega L equal to J omega C3 R1 into R4, that is J omega C3 R1 R4. So J omega C3 R1 R4 plus J omega C3 R1 into 1 upon J omega C4. So we get J omega C3 R1 divided by J omega C4. So we get R2 plus J omega L equal to J omega C3 R1 R4 plus J omega C3 R1 divided by J omega C4. This J omega get cancelled with this J omega, and we can write this R2 plus J omega L equal to J omega C3 R1 R4 plus C3 R1 upon C4. Say it is equation number 3. Then equation 3 contains two parts, that is R2 is real part, C3 R1 R4 it is real part, and J omega L imaginary part, term containing J omega imaginary part. So equating real parts equating real parts, we get R2 equal to C3 R1 upon C4. R2 is equal to C3 R1 upon C4. If we solve this, we get R2 by R1 is equal to C3 by C4. R2 by R1 is equal to C3 upon C4, and equating imaginary part, we get j omega L equal to j omega C3 R1 R4. J omega C3 R1 R4. So this j omega get cancelled with this j omega, and finally we get L equal to C3 R1 R4. So L upon C3 is equal to R1 into R4. So this is the final formula, that is L upon C3 is equal to R1 R4. We can compare inductance L with capacity C3 by using this formula. So this is the application of Owen's bridge. We can compare inductance L with capacity C3 by using formula L upon C3 is equal to R1 into R4. So that ends your article Owen's bridge. Also your first topic AC circuit is completed. So let us stop here.